At 5:33 in the morning, the feed mill in the Texas Panhandle begins its first mix of the day. Outside, the temperature sits at 38 degrees Fahrenheit. The flat land stretches in every direction under a sky still dark at the western edge, pale gray at the east. The wind, a constant feature of the Panhandle, moves across the pen surface at 12 miles per hour, carrying the smell of cattle and dry soil and something mineral that belongs entirely to this geography. Inside the mill, a corn moves through the steam flaker at a continuous feed rate. The rollers compress each kernel into a flat disc, approximately 1 millimeter thick. Density checks run every 30 minutes. Target, 26 pounds per bushel. The mixed ration accumulates in the batch mixer: steam-flaked corn, wet distiller's grains sourced from an ethanol facility 47 miles east, alfalfa hay, a vitamin-mineral premix, and a liquid molasses component that improves palatability and reduces dust in the mix. By 6:15, the first delivery truck pulls out of the commodity bay. The load, 22 tons. The route, 14 pens in sequence, each receiving a calculated quantity tied to the pen's stocking density, the cattle's average days on feed, and the bunk reading from the previous evening's delivery. The computer delivered those quantities to the driver's cab display before the truck left the mill. Cargill's feedlot operations in the Texas Panhandle hold combined annual capacity to finish over 500,000 head of cattle. The feed mills mixing rations for those operations process more than 1,000 tons of ingredients daily. The electronic identification systems tracking every animal in those pens maintain individual records on hundreds of thousands of cattle simultaneously. And the Cargill beef processing facilities that receive finished cattle from these yards sit within practical trucking distance, completing the integration between feed, feeding, and harvest that defines the economic logic of large-scale industrial beef production. The Texas Panhandle became the center of American cattle feeding geography through a convergence of factors that were never individually designed to produce that outcome, but collectively made it inevitable. Water from the Ogallala Aquifer underlies the region at depths that allow economical pumping. That grain, primarily sorghum and corn grown on irrigated Panhandle fields or transported from the Kansas-Nebraska Corn Belt, supplies the energy source that high-performance finishing rations require. The climate combines low humidity with consistent wind, two factors that reduce the respiratory disease pressure and mud management challenges that feedlots in wetter regions face. And the land is flat, inexpensive relative to productive agricultural regions, and available in quantities that large-scale operations require. Cargill entered the cattle feeding business as an extension of its grain trading operation, a company that sourced, stored, transported, and sold grain already occupied every position upstream of cattle feeding, except the feeding itself. Moving into feeding, captured additional margin from the grain that Cargill already handled, created a guaranteed outlet for commodity corn that absorbed supply during periods of oversupply, and built a direct connection to the beef processing capacity that Cargill also developed. The integration, grain origination to cattle feeding to beef processing, represents vertical control across 3 of the 4 major cost centers in beef production. The ranching operation that produces the feeder calf remains outside Cargill's direct control, but the procurement function that buys those calves and places them on feed operates with the information advantages of a company that simultaneously manages the grain supply and the harvest schedule. Feeder cattle arriving at a Cargill Panhandle yard typically weigh between 600 and 800 pounds. They come from ranches across Texas, New Mexico, Kansas, Oklahoma, and the broader plains and mountain states, purchased through a combination of sale barn acquisitions, direct ranch contracts, and video and electronic auction platforms that allow procurement without the cost of physically moving cattle to a central location before purchase. The cattle that perform best in Cargill's feeding system carry moderate to large frame scores, genetic indicators of the mature body size that determines how much lean muscle the animal can carry at harvest weight. A large frame steer, placed at 750 pounds, will typically require 150 to 180 days to reach 1,300 to 1,400 pounds, gaining an average of 3.0 to 3.5 pounds per day on a high-energy ration. A small frame steer placed at the same weight may reach adequate fat cover at a lower market weight and shorter feeding period, but the carcass it produces may fall below the weight specifications that processing plant scheduling and retail buyers require. The procurement team at Cargill's Panhandle operations manages these specifications continuously, adjusting the genetic profile of incoming cattle based on the carcass weight and quality grade targets that the processing plant schedules communicate back to the feeding operation. When the plant needs more prime quality carcasses, the procurement team sources cattle with the genetic background, typically higher proportions of English breeds like Angus and Hereford, that marble more readily. When plant throughput demands heavier carcasses, they source larger frame cattle or extend feeding periods. Incoming cattle move through a processing sequence within the first 24 to 48 hours. Each animal receives a visual health assessment, a vaccination protocol covering the primary viral and bacterial pathogens associated with bovine respiratory disease, an internal parasite treatment, and a growth-promoting implant in the ear. The electronic ID tag, applied at this point, links the animal to its individual record: purchase date, source, arrival weight, processing protocol, and every subsequent health observation for the duration of its feeding period. The feed delivery system, running 1,000 tons of mixed ration per day to hundreds of pens across the yard, operates on a precision that the scale requires, but that visitors rarely expect to find here. The computerized delivery management system knows for every pen in the yard the stocking density, the average days on feed, the current ration phase, and the previous feeding's bunk condition. Whether cattle cleaned up all the feed delivered, left some over, or cleaned up so quickly that the bunk ran empty before the next delivery. That bunk condition reading, assessed by the feed truck driver during the previous delivery and entered into the cab-mounted system, adjusts today's delivery quantity upward or downward from the formula target. The goal is ad libitum intake. Feed available continuously without excess accumulation that sits in the bunk long enough to heat, mold, or develop palatability problems that reduce intake on the next feeding. A pen that cleaned the bunk completely before yesterday's afternoon delivery may be receiving slightly more feed today. A pen that left 3 inches of unchewed feed at the back of the bunk receives less. This bunk management discipline, the daily adjustment of delivery quantities to match cattle intake patterns, sits at the center of feedlot nutrition management. Cattle on high-energy finishing rations near the end of their feeding period, consuming 2.5 to 3.0% of their body weight in dry matter daily, produce enough heat from ruminal fermentation that summer temperatures regularly suppress their peak intake capacity. A Panhandle summer day that pushes past 100 degrees Fahrenheit shifts cattle intake from the afternoon delivery, when the animals are heat-stressed and eating less, toward the overnight and early morning periods after temperatures drop. The feed delivery schedule adjusts for this. Morning deliveries are heavier during summer months. Afternoon deliveries are lighter. The total daily intake target per pen holds constant, but the distribution across delivery times shifts to match the cattle's behavioral response to temperature. The on-site veterinary hospital at a large Cargill Panhandle yard is a working medical facility measured not by patient volume in dozens, but in dozens per day. Bovine respiratory disease. The viral and bacterial respiratory complex that remains the leading health cost in North American feedlot cattle attacks newly arrived animals most severely in the first 14 to 45 days after placement, when the stress of weaning, transportation, commingling with unfamiliar cattle, and exposure to new pathogens combines with the immunosuppressive effects of that stress to create a disease susceptibility window. A pen of 200 cattle placed 10 days ago may generate 3 to 6 treatment pulls per day during a BRD challenge. The same pen at day 90, fully acclimated, might go a week between single animal treatments. The pen rider identifies sick animals during morning observation. The health crew pulls flagged animals to the hospital, moves them through a processing chute, conducts a physical examination, temperature, respiratory rate, lung sounds, attitude, and makes a treatment protocol decision. The electronic ID system records each examination and treatment, what drug was administered, the dose, the route of administration, and the withdrawal period before the animal is eligible for harvest. Withdrawal period management is a regulatory compliance matter, not an optional consideration. Antibiotics administered to feedlot cattle carry mandatory pre-harvest withdrawal periods, typically 14 to 28 days depending on the compound, during which the animal cannot enter the human food supply. Cargill's electronic ID system flags animals with active withdrawal periods and prevents their marketing until the withdrawal clears. An animal pulled for antibiotic treatment at day 140 of a 160-day feeding program cannot ship to harvest on day 155 if the withdrawal period extends to day 158. Treatment outcomes, whether the animal recovered, required a second treatment, became a chronic that didn't respond to standard protocols, or died, enter the health records and accumulate into performance data that the veterinary team analyzes by source group, arrival date, season, and treatment protocol. That analysis drives adjustments to the arrival processing program and identifies which source groups carry higher health risk that procurement can factor into buying decisions. Water management in the Texas Panhandle operates under constraints that are fundamental to the long-term viability of feedlot operations in the region. The Ogallala Aquifer, the primary groundwater source for the Panhandle's agriculture and livestock operations, has been declining for decades under the combined draw of irrigated crop production, municipal use, and industrial water demand. The aquifer does not recharge at rates that come close to matching withdrawal. In portions of the Texas Panhandle, the saturated thickness of the Ogallala has declined by more than 50% since widespread irrigation and industrial water use began in the mid-20th century. Cargill's feedlot operations use water for cattle drinking, dust suppression on pen surfaces and alley roads, pen cleaning operations, and processing facility needs. The water recycling systems that capture runoff from pen surfaces, contaminated with manure but retaining hydraulic value for dust control, reduce the fresh groundwater requirement for non-potable uses. Recycled water from settling ponds applies to pen surface irrigation as a dust control measure, reducing the volume of clean groundwater required for that function. Dust control is not merely a neighbor relations issue. Dust from feedlot pen surfaces contains dry manure particles, soil, the feed ingredients, and biological material that, under dry and windy panhandle conditions, can rise into plumes visible from miles away. The Texas Commission on Environmental Quality regulates feedlot dust emissions under the Texas Clean Air Act, and operations that generate excessive fugitive dust face enforcement action that can affect operating permits. The water from the recycling system also captures soluble nutrients, nitrogen and phosphorus from manure dissolution, that would otherwise move with dust or runoff toward groundwater. The captured nutrient-laden water, applied back to pen surfaces and surrounding cropland, keeps those nutrients in productive agricultural use rather than contributing to off-site water quality impacts. The marketing of finished cattle from Cargill's Panhandle feedlots to Cargill's beef processing facilities represents the integration point that justifies the entire system's structure. At 1,300 to 1,400 pounds live weight, with adequate fat cover to meet the yield grade specifications that retail beef buyers require, a pen of finishing cattle generates a marketing decision that the feedlot's management team makes in coordination with the processing plant's kill schedule. The plant needs a certain number of cattle within a certain weight and quality range on specific harvest dates. The feedlot has pens approaching readiness on an accelerating schedule as 150 to 200-day feeding periods complete across the yard. Through pre-harvest ultrasound scanning, running a probe across the ribboned loin area of representative animals from each pen, generates direct measurements of back fat depth and ribeye area that predict carcass yield grade and confirm that the pen has reached the fat deposition level consistent with USDA choice or higher quality grade. A pen that ultrasounds at 0.45 inches of back fat with adequate ribeye area is ready. A pen at 0.30 inches needs more time. And that data feeds into a marketing schedule that commits specific pens to specific plant dates 3 to 7 days ahead. The committed schedule drives the transportation logistics, the number of trucks, the loading sequence, the departure time from the yard, the expected arrival time at the plant gate. At a Texas Panhandle plant, receiving several thousand cattle per day, the scheduling precision required to run the kill floor at target capacity without extended cattle holding is significant. The carcass data that comes back from the plant, hot carcass weight, yield grade, quality grade, any defects noted at inspection, returns to the feedlot's performance database and closes the loop on each pen's record. The yield grade and quality grade distribution from a pen correlates against the pen's feeding history, source, genetics, and ration program, building the analytical foundation that Cargill's team uses to refine procurement specifications and feeding protocols. The 500,000 head annually, at an average feeding period of 175 days, that annual throughput implies a standing inventory of approximately 240,000 head at any moment across the Panhandle yards. Those animals gain an average of 600 pounds each during the feeding period, from 750 pounds average placement weight to 1,350 pounds average market weight. Total pounds of gain produced by the system annually, 300 million pounds of live weight gain, converting to roughly 175 million pounds of carcass weight that flows through Cargill's processing operations and into the beef supply. The corn that fuels those gains at a feed conversion ratio of approximately 7 pounds of dry matter per pound of gain, represents more than 2 billion pounds of grain-equivalent ingredient flowing through Cargill's centralized mills annually. That grain requirement connects the feedlot operations directly to Cargill's commodity grain origination network, the elevators, the rail, and truck logistics systems, the futures hedging positions, and the supplier relationships that move corn from Corn Belt fields to Panhandle feedlot bunks. The integration is complete at every level: grain origination, feed production, cattle finishing, beef processing. To the animal that enters a Cargill Panhandle yard as a 750-pound feeder calf moves through a system where every handoff, from commodity purchase to feed delivery to pen management to harvest scheduling, occurs within a single organizational structure with shared data and coordinated decision-making. The feed truck leaving the mill at 6:15 this morning is not an independent operator making a delivery. It is one movement in a system calibrated to convert grain and cattle into beef, with a precision and continuity that no collection of independent operations could replicate. At 5:33 in the morning, the mill began its first mix. By 8:45, the first delivery is complete. The pens are fed, the cattle eat. Tomorrow, the same. If this deep look at one of the largest cattle finishing systems in the American West gave you a clearer picture of the scale and integration behind industrial beef production, hit the like button and help more viewers find content that takes these systems seriously. Subscribe for more stories that go behind the numbers of modern food production, the infrastructure, the logistics, and the economics that most people never see. Drop a comment and tell us where you're watching from. We check them all, and the geography of this audience is always a reminder of how far these stories travel.